Hello. So yeah, finally we are live. I'm Adavan. I'm planning to write a Golang application to reset Kafka consumer group offsets, and I thought I'll also put this uh, experience in YouTube stream so that it helps some people. So yeah, let's start with some whiteboarding to understand what is Kafka, what is a consumer group, and what is a consumer group offsets, and then we can start coding from there. So without further ado, let me open my whiteboarding tool. Let me make this big. Yeah. So to start with, as you might know, Kafka is a message bus, which is mainly used for asynchronous communications. So this is Kafka, and there are two parties generally around Kafka. One is the producer. This is a producer, and the other party is consumer. So things are simple here. So producer produces a message, and the consumer is going to read message. So it's going to read message. Now, how does Kafka stores the message? The messages when the producer produces them. So Kafka has this concept of topics, and each topics can be divided into each topics can consist of multiple partitions. So this is P1, this is P2, and P3. So the number of partitions can be configured while creating a topic. So these are partitions, and each partition is nothing but an immutable log. It's an immutable log. So what do I mean by immutable log is assume this is our log file, and then the first message is published. It comes and stored in M1. So this is partition P1, assume, and then another message is produced. So then it is appended to M1. Then the next message, M3, it goes on, and the final message, for example, it's stored as Mn. So the new messages are always appended to the log, and the log is immutable. Now each message has a pointer, a numeric pointer, which is called an offset. So for example, assume this is the offset for message M1 is 1. The next message offset is 2, the next message offset is 3, and finally the last message offset is n. Now let's see what is a consumer group. So there could be multiple consumers reading a single topic, and now each topic is divided into multiple partitions. So this is P2. Assume that we have MP1 here, MP2. These are messages in partition 2, P3, something like this. Now there could be a consumer group can contain multiple consumers. So this is a consumer group, and there could be consumer 1 and consumer 2. Now each partition is going to be uniquely consumed by a consumer. Now assume that partition P1 is consumed by C1, and partition P2 is consumed by C2. It's going to read, yes. Now we need to store some checkpoints for these consumers here in order to identify the last read position, so that if this consumer dies and it comes back, it has to read from the read messages from the last read position, so that it doesn't duplicate any messages. It doesn't duplicate processing of any messages again and again. So consumers it reads from partition 1, and then it also has this information of offset. So it goes to every time when it reads a batch of messages, say for example, it reads the 3 messages from partition 1, and then it commits this offset as the last read offset to Kafka. And inside Kafka there is a special topic called __ consumer _ offsets. So this topic is going to have a bunch of information about each consumer group. It has the group name, and then it has the topic name, and then it has the partition name, and finally it is going to have the offset, which is last read. So for us, group name, say assume G1, topic name is T1, and then the partition here is P1 for consumer C1, so let's say P1, and then the offset last read is going to be 3. So when this consumer C1 dies and then it comes back, it is going to see the last read offset, and then it is going to read from the next message, which is M4 here. So this is how Kafka works, and this is how consumer group stores their offsets against the topic that they are reading. Now what we are going to do is we are going to try to build a tool which is going to play with this consumer offsets topic. It is going to alter, it should have the capability to alter the offsets, the last read offset. Say assume that our tool should technically change this value here, so that if you say 1, then technically C1 has to reprocess all the messages from M2 and M3 until Mn. Now why do we want to do this? Sometimes it is necessary that we have to reprocess all the messages, and then resetting offset in Kafka, it's a little bit difficult, I would say. So I thought I would write an application with simple interfaces which makes which manipulates this last offset read, and then it will enable us to make all our consumers reprocess all the messages. Now enough talking. So we can go to the actual coding part. So yeah, I'm going to name this project as maybe ReOffset. Or we can also name it as offset master. Yeah, let's keep it ReOffset for now, because I like this name really. So let me go here. Let me create initialize Go module here. Now let me create this main.go file. All right, so let me make sure that it runs. All right, our setup is perfect. Now I'm going to use the Confluent Go library, package.go.dev. So I go to package.go.dev and then look for Kafka packages. So I'm going to use this Confluent Kafka Go package for our application. Now this is a wrapper around a C library called Liberty Kafka, and then writing application using Confluent Kafka Go is a bit easy. So there are other nice libraries, something like Sarama, which is a pure Go implementation to deal with Kafka. But yeah, today I'm going to use Confluent Kafka Go. So let me quickly jump to the index. Okay, let me check the application. So we have something called admin client, and yeah, we have some functions called alter consumer group offsets. What does it do? So alter consumer group offsets alter the offsets for topic partitions for consumer groups. So exactly this is what we want. So we change the consumer group offsets, and then we are going to make consumer read messages from the beginning. All right, so in order to get alter consumer group offsets, we need an admin client. Okay, so where do we start? So I'm going to write this application from backwards, from the last step, and then we'll slowly move backwards to in order to finish the application. So the first thing I need is I'm going to call a function called alter group offsets, and this function is going to need group name. It is also going to need a topic, and then it is going to need a list of partition, and then the offsets that we want to change. So both of these are string, and then finally offsets, which is going to be map of int for now. Sorry. This is not the function definition. Sorry. Now let's create a function called alter group offsets, where group topic is a string and offsets is a map of int, and this is going to return an error for now, and we can improvise later. So let's return an error for now, and then let's say return null. Now this is complaining it doesn't have group topic and offsets, so let's create those variables here. Assume topic. Let's start with something, let's call it as test topic, and our group is the group where I want to change the offsets. It is going to be test group, and then for now, let's keep an empty map. All right, so here let's check if error not equal to nil, and then so if we cannot alter the group offset, then technically our application has failed to do its core job. So let's write to std error. So let me create one more application, func write error. So this is going to have format. So this is going to have a format string, and then it's going to have a bunch of interfaces. So here we can write if and I'm going to write to std error format, and then a, which is nothing but our arguments. All right, so here I'm going to say write error, and then I'm going to say error while altering group offsets. And now let's exit off. All right, now this should technically run. Yes, so we don't have any errors here. Now how do I what else do I need? So I want to write the plan before altering the group offsets, so that it works like Terraform, where we say, oh, okay, hey, like this is my this is the existing offset stored and underscore consumer offsets topic, and like this is the offset that you're trying to change. Are you sure? Confirm, something like that. So in order to do that, we need to fetch the existing offsets. So we know the group name, and then we know the topic name. So let's fetch current offsets. So I'm going to need one more function called fetch group offsets, and then this is mostly going to need a group, the group name, and then the topic name. Okay, so let me create this function as well, func, and then both of them are string, and this is going to return a map of integers and integers, where the key is going to be the partition numbers, and then the value is going to be the offset stored. So let's say current offsets is going to be map of inch, and then return current offsets. Here let's return inch and int, or probably we will return the map, or if there is an error we will let's return an error as well. And yes, so here we need to check for error as well. If error if error not equal to nil, then I'm going to paste this here, and then also error while fetching group or current group offsets, and then I'll return. So this is complaining because okay, the error is already declared. Sorry. All right, so we have fetched the current offsets. Now we need to write a plan. How do we write a plan? So we need to write this plan to std out. So what I'll do is I'll duplicate this method, and then I'll call it as write output, and then instead of std error it's going to be std out. Yes. All right, so let's go to the top. So we have current offsets, and then we know the offsets that we want to change. So let's write something like write output plan for altering offsets to topic. It's a string, and then it's going to be a topic, and then so I want something like plan. The output will be plan for altering offsets to topic. Assume, say our topic name is customers dot events. So this is our topic name, and we will the output follows something like this. So we will have a line of we'll have a line of hyphens to make it a little bit pretty, and then we'll say partition p1 current is, say, offset number is 2, and then we'll say 3. For partition 2, the current offset is say 656, and then we want to change it to 100. So we need something, some output, something like this, and then say, yeah, this is enough for now. So this is what we want. So let's go here. So we have written the first line here, or probably I'll do something like plan message. So I'll use sprintf to format this message. So I'll write plan message first. Now we need a line, one more line where we get all this hyphens. So let's get the length of plan message. Length of plan message, and then I'm going to run a for loop for assume I equal to 0, I less than message length, I plus plus. I'm going to write fmt or write output, which is nothing but sorry, which is nothing but a list of hyphens. Once we do that, we have to write \n so that we get from this line to the new line, and then we need to loop through this offsets here. This is offset that we want to change. Offsets, this is a map of partition to offsets that we want to apply. So we want to we want to apply these offsets, and like this is our current offsets. So what we do is we can loop through offset. I'll say PO range offsets, and then I'll say write output, which is nothing but P and then %d, which is going to be this P1 here, and then I'm going to call current offset. Or let's say offset. I'm again going to write a format specifier for integer, which is going to be our current offset, and then I'm going to change and then write the new offset that we wanted to change. So this is going to be P, and then I want to get the current offset for this particular partition. So current offset of P, and then I'm going to set O here. Now after this, let's put a new line. So we are pretty much done in writing the plan. So let's do one thing. Let's extract this to another function. So let me call this as write plan, and then I go here, write plan, and then I'll paste it here. So in order to write plan, we need topic, which is a string. We should also need the group name. So that we can say plan for altering offsets to topic %s and group. And finally we need current offsets as well. We need current offset, and then we need offsets, right? Let's call it as planned offset. And this is both of them are map of integer to integer. So let me call them as planned offsets. So we need topic, group, current offsets, and planned offsets. Let me go here. So first of all, we need the topic, we need the group, and we need the current offsets, and then we need offsets. So let's rename this to planned offsets. So yes, now we have some methods to write the plan. So our flow is almost done, where we can try to print the output of this function with some dummy inputs. Say for example, I can say planned offsets for partition 0 is going to be 3, and then the planned offset for partition 2 is going to be 100, very similar to the expected output here. And I go to fetch group offsets. And then here let's say current offsets of partition 0 is 2, and then for partition 1 it is 656, right? Now let's see how it works. So go run main.go. Yes, so plan for altering offsets to topic test and group test group. So we are missing we are missing a new line character here. Okay, so this is as expected. So we got the hyphens till the heading of the first line, and then we have a very nice plan which says for partition 0 we are going to change the offset from 2 to 3, and for partition 1 we are going to change the offset from 656 to 100. This is perfect. So now we have written an outline which is working. So now we can dive into the package that we have seen earlier, which is Confluent Kafka Go. So we can pull this package, and then we can use real methods to actually pull data from Kafka, and then we can change the offsets. So let's do it. All right, so first of all, to get to alter consumer group offsets, and then do we have a method to fetch consumer group offsets? Describe ACLs. Let's see a method. Let's search with offset. Okay, there is a method called list consumer group offsets. So what does it do? List consumer group offset fetches the offset for topic partitions for consumer groups. Yeah, looks like this is what we want. So so let's do this. Let's duplicate this tab. Let me go to the okay, it's here. So let me pull this module. So go get, yeah, and we should be able to see this in our go.mod. Perfect. Like this is indirect because we still have not used this package in our application. So let's start using this. So first of all, looks like in order to use list consumer group offsets, like we need an admin client. So we need to create an admin client first of all, and there are some methods to do that. So there is similar to a constructor method, like which gets new admin client. It's called new admin client, and then it returns an admin client and an error, and then it is going to get a config map as an argument, and this config map is a map of string to config value, and then config map is a map containing standard library configuration properties as documented in this. So let me open this file. Okay, so let's do one thing. Let's create something called Kafka client. Right, and then this is going to say let's call it as admin, which is nothing but Kafka Kafka.admin client. Now we have already used this Confluent package in our application. Now if I go to go.mod now, it must have been changed. This is interesting. Like, this should have been changed to direct now. Okay, let's see how it goes. All right, so now this Kafka client, let's write some functions called methods called key star of Kafka client. Let's call it as new, and this is going to return as just error. So here we can write something called client comma error is going to be Kafka dot new admin client that we want, and this is going to need a config map. Wait a minute, do we want to call this function here, or should we need to initialize the admin client in our main.go I mean like inside our main function, and should we need to pass this to new? By passing that, we will be able to mock this object during tests. So let's call it as Kafka.admin client, and then this is going to return two things. One is Kafka client, and then the other one is error. So then this shouldn't be a method, like this is a normal function. Say new new Kafka client. Now it is going to just return Kafka client, where client is nothing but client, and then the error is going to be nil. This is admin, sorry. So new Kafka client is going to initialize this struct for us with an admin client, and then we'll have a method to fetch consumer group offsets. So we have written this already. So let me go. So we have something called fetch group offsets, right? So I'll move this to here, and then I'll just make this as the method for Kafka client under Kafka client. So this will be Kafka client. No. Key star Kafka client. Yes. Let me close this. All right. So now this method, now it will be able to call this function called what's that, list consumer group offsets. No, this is an option, so list consumer group offset. Yeah, like this is what we want. So this list fetches the offset for topic partitions for consumer groups. Yes, so this is what we want. So result, let's call it as result comma error is going to be k.admin.list consumer group offsets, and then we need a context. For now, let's call it as context.background, and then we need group partitions, and then we have a list of options. So what is group partitions? So this is called Kafka consumer group partitions. What's this? So it has the group name, and then it has a list of partitions. Consumer group topic partitions represent consumer group's topic partition. So let's say group partitions is Kafka.group what's the name, consumer group topic partitions, consumer group topic partitions, which is a struct, and this function needs an array of this. So I mean like a slice, sorry. So let me try to fill structs. Yes, so this group is nothing but the group that we get from the parameter here, and then what do we need in this partitions? Let me go here. A topic partition is a generic placeholder for topic list partitions and optionally offset. So it has the topic partition offset metadata error and leader epoch information. So we don't have this information except the topic name. How can we specify this? Let's read the API again. So let's go to list consumer group offsets. Group partitions, a slice of consumer group topic partitions, each element of which has the ID of consumer group and the slice of the topic partition we need to fetch the offsets for. Yes, the slice of the topic partition can be nil. Okay. Fetch all topic partition for that group. Okay. So yeah, so this is how it is going to be, this is how it is going to work here. Let me so the concept here is now we know that consumer group offsets are stored under this topic, special topic called consumer underscore offsets. Now a consumer group can technically read multiple topics. So CG1 can read from topic 1, topic 2 at the same time, and then it is going to store now each of these topics are as we discussed before, each of these topics are divided into partitions, and this is going to have multiple partitions. This is P2. Now, how things are going to get stored in consumer group offset is, for CG1, say this is topic 1, topic T1, and this is topic T2. So underscore consumer offsets topic is going to have records like CG1, topic T1, and then for partition 1, the last read offset is say 21. No, it is very similar, but like the representation is something like this. So when you describe a consumer group, it will be like CG1, then we have topic T1, and then for P1 last read offset is 21, P2 is 32, something like that, and then it has it has topic T2, partition 1, 35 maybe, and P2 is 45. Now under the same consumer group, there can be records for multiple topics T1 and T2, and we are interested in topics where we have passed as parameter, right? So what this says is like the slice of topic partitions can be nil to fetch all topic partitions of the group. Currently the size of group partition has to be exactly 1. So we can technically we'll set this to nils to get all the topic information under group partitions, and then we can filter it based on the topic parameter that we pass into this function. So so this is our group partitions, yes, and then finally we need to pass on more information, which is consumer group offset admin option. What is this? List consumer group option C set admin request timeouts, set admin require stable offsets. Probably we don't need these functions for now, and then they are variadic functions, as you can see here. So sorry, it's okay if you don't set these functions. So yes, if error not equal to nil, and then we will return nil comma error. So we'll delete this. So we have our results here. Let's see how this function is returning the result, so that we can just get the offsets for the topic that we are interested in. So we have to do some more processing here. So let me go to the the API definition. So it is returning list consumer group offsets result, which is again a slice of consumer group topic partitions. So let's call it topic, let's name it as topic results, which is nothing but result dot consumer group topic partitions. Or like we don't need this, because it's already a slice, so we can range through it, and then we will pick only the topic that we are interested. So for k comma v range result consumer group topic partitions. Actually we don't need the index for now, so I'll put an underscore now. So what is this consumer group topic partition? So consumer group topic partition, it's going to be the group and then a slice of topic partition. Okay, so it's so similar. So for each consumer group topic partition, there is another topic info. So we need to loop through that, because we need to loop through these partitions, and then I assume like it has this topic name, which is what we want. So topic information is range v dot partitions if t dot topic is the topic that we are interested, then we need those partitions. So does it contain an offset and a partition? Yes. So it has a partition and then it has an offset. So we can say current offset of t dot partition, it's going to be t dot offset. All right, like we have converted this to integer. Let's see how it works, and we can finally check whether we need this conversion or not. So I'll write a to do. Do we really need this integer conversion, or can we change the type? All right, so what we do is like we get the result. Once we get the result, we'll range through the partitions inside the result, and then we check if the topics are same, if the topic name is same as the topic that we are interested, and then we get those offsets and partitions, and then finally we return it here. So how do can we run this application now? Is there an error somewhere? Okay, here. So fetch offset is failing because it should be something like client dot fetch group offsets. Now we don't have a client, so let's create a client. So admin, remember, like for a new Kafka client, so we need to pass let's call it as client. So we need to pass admin client here. Now we don't have admin client, so we will create an admin client. So Kafka dot new admin client, and then it needs a list of config. So Kafka dot config map. So what is this kafka.config map. Let me go to the definition again, new admin client, config map, and then config map is a map containing standard libbody configuration properties as documented in this file. Okay. Okay. So this is why I like Confluent Kafka Go library, because setting all these configuration is a bit easy. Like I did not find setting configurations easy in other libraries out there. And then we have this great documentation for each of the parameters that we want actually. So in order to test our applications, I think like we need only bootstrap servers. What else do we need? Yeah, right now like we can just set the bootstrap server. So config map is a map of string to config value. And what is config value? It's an interface. It can be a bool, int, string, any type with standard string interface. Okay. All right. So the first thing is going to be bootstrap dot servers, and then our value is going to be, let's spin up a local Kafka cluster in order to test this application. So I'll run a Docker container after writing this function. So the value will be 92. I think like this is the only configuration that we need. What is this? Client ID. We don't need other information, I think. Let's check this. Let's see how it works, and then we can decide what other, we can figure it out later. So we created an admin client, and if error, if we get an error creating admin client, then that's a fatal error. So let's say error creating and then I'll pass this error, and then I'll our application should exit, because like we cannot move forward when the admin client creation fails. os.exit of 1. No, I don't want this. All right. Now, let's create, we need a Docker file for to test this application. Actually, I had a Docker file somewhere. Kafka experiments, yes, and then yes, we have a Docker compose file here. So I have a Docker compose file which I copied from the internet, from Confluent Docker setup. Yes. Yeah, like this is a repository where, I just get the Docker Compose file. So usually I'll go with CP all-in-one, where I think it has all the required containers for a complete Kafka setup, which has schema registry, ksql db. It has a control center, connect. No, this is not the one. I think like it's CP all-in-one. Yeah, like it has Zookeeper. The recent versions of Kafka, they don't use Zookeeper. They work in a craft mode, but then like let's use Zookeeper for our for our testing. So it creates a broker, schema registry, connect. We don't need all these informations. Okay, so for now I need only the Zookeeper and the broker, and I don't need anything else. So let me delete everything. Okay, let me create first of all, let me see. I don't have any orphans, so I'll create Docker Compose up. Okay. So there is a conflict. I think I have to go to dev Kafka experiments. Yeah, Docker Compose, remove orphans. Yes. Now I can run this Docker Compose. So it has created a Zookeeper, which is for Kafka coordination, and then it has created 2 brokers. May not be the right number of brokers, but yeah, for testing it's okay. TPS. Yes. So we have 3 containers, and like the Zookeeper, we are not interested in it for now. So we have a broker which is running on 1992 and port number 1993. Perfect. So let's run the application and let's see how it behaves. Probably I need one more setting from the libbody configuration, something like a timeout. Yes, this is a bit hard to. Let me check the code. So I need something like a timeout so that I know I don't want to wait for Kafka if my Kafka is slow to respond. So we have created bootstrap servers here. We have used this. Default timeout for network requests. Producer will use the socket timeout. Okay, we can use this. Is there any other timeout? Timeout. Which timeout is this? I think let's try to use socket timeout.milliseconds. Socket.timeout.milliseconds. So let's make it as 3000 so that we wait for 3 seconds for. So this is what default timeout for network requests. Okay. All right, so let's run main.go. Let's see. So our application did not fail, which is a good thing. And then it is trying to read fetch group offsets. Previously, we were sending our hard-coded numbers. Now we are actually getting 0 because we don't have topics. We don't have any topics with a name called test and test. We don't have a consumer group as well. So that could be the reason why we are getting 0 from here. We can actually return, it's quite interesting, it doesn't return an error when it is not able to find the topic and the offset. Probably one of the improvement that we can do is we can check if the topic exists, and if the topic doesn't exist, we can throw an error, but we can do it later. So let's create a topic called test. So I use this tool to to create let's see, with 5 partition I'll create a topic called test, right? And I can actually produce Kafka produce, and I can specify partition, and I can specify some values. Okay, Kaf produce -p. So I'll produce to partition 1. Hello, how are you? This is produced to partition 1. Perfect. So you can see, as I did, told you before, each topic now it has 5 partitions, which means it has 5 different log files maybe, and then each message that we write, it goes to partition 1 here, and then the offset usually starts from 0, 1, 2, 3, but may not be always necessary to start from 0. It depends on, sometimes usually it starts from 0 technically. All right, so we have 6 messages. Let me try to consume from this partition. So for consume, I can specify my group name. I can tell the CLI to commit my last read offset. So kaf consume hyphen group. So I'll say test group, and then hyphen commit, and then I'll say I should read a test topic. Let's see. Okay, so now it has read. Now it has read the information. See the messages. You can see the messages. Hello, how, here is how, here is R, U, and all the messages. And this is a final message to partition 1. So I'll stop here. Let's see if we have this topic called topics consumer underscore offsets. Yes, we do have this information. Like, we have a topic called consumer underscore offsets, which is a special topic that we have where the consumer offsets are stored. Probably, we can try to read what is there, what is stored inside this topic. So consume, and then we have some information for test group, but it's not so obvious to read from this topic, but like definitely we have some information for test group. All right, now when I run main.go, actually it should not show 0. It should show some other numbers. Let's see. It still shows 0. Why? Probably, let's print here v dot partitions, and then let's print got topic name t dot topic. So what is this? Topic as string. Okay, so it's a string pointer. So I think we are trying to compare the address instead of the values. So we'll dereference this, and then let's say let's also dereference this, and then say go run main.go. Yes, so now we have this information properly, where where we have for partition P1 our current offset is C1, and then we are trying to change it to 3, and we don't have any messages in partition 0, and then the consumer never, so technically the consumer can never consume from partition 0. So we don't have this. So yes, now let's remove this debug statements, and let's run for one final time. Yes, so perfect. So we were able to fetch group offsets, and we were able to write the plan that accordingly. Now the final thing that we want to do is we need to alter the consumer group offsets, and then we should be able to test that as well. Now I want to, before that, I want to show you another behavior here. So when I produce for test 1, like this is my new message, right? Now when I try to consume hyphen group commit test, so I'm going to use the same consumer group name called test group, and then I'm going to read from the topic test. What happens is, like, the behavior now, it should read only this last message produced, because like in our offset topics, in our consumer underscore offset topics, we have the last offset stored as 7. So should read yes. So this is now reading only the last message. In case if I change the group name to something new, and then it is going to read all the message from the beginning here, from hello to all the way down to this is my new message. So if I run go run main.go, our offset has to be incremented, yes. So let me produce some messages to offset 0 as well. This is a message in offset 0. All right, so our usual group is test group, right? Yes, test group. Now I'm going to read, now it is going to read from partition 0, yes. I'll stop this. If I run go run main.go, yes, it is going to, it fetched the correct offsets, and then it has returned the plan well. Perfect. All right, let's see our final method to alter consumer groups. Let me get the definition. Alter consumer group offsets. Not this, right? It should be admin client. Should be a function of, no, alter consumer group offsets admin option. Should be this, alter offsets. Yes, this is what we want. Alter consumer group offsets. Now alter consumer group offsets, it needs a context, and then it needs group partition, which is nothing but again the group name and then the partitions. So inside the partition it is the same. We need the topic name, we need the partition, and then we need to set the offset. 3 informations. So let's go back. Let's read the documentation bit. Alter consumer group offsets alters the offset for a topic partition for a given consumer group. Context is a context for the maximum amount of time to block. Group partition is a slice of consumer group topic partitions, and each element which has the ID of consumer group, we want to pass this name of the consumer group here, and the slice of the topic partitions we need to alter the offsets for. And then we have the options. returns an alter consumer group offset result containing a slice of consumer group topic partitions corresponding to the input slice plus an error that is not nil for client level errors. Individual topic partitions inside each of the consumer group topic partitions should also be checked for errors. So it has some errors, I guess. So let's go here. Yeah, so we need to check for this error actually. So I'm going to close this and then let's move this function as a method under Kafka client. So this will be k star Kafka client, right? So the information, like it has all the information that we need. It has the group, it has a topic, and then it has the offsets. So let's change this to offsets. And then it is going to return an error. Okay. So now what do we want is our method is going to return two values, which is result and error. So we'll call k.admin.alter consumer group offsets, and then we can call context background for now, and we need consumer group topic partitions. So group, let's call this planned group partitions is going to be a slice of Kafka.consumer group topic partitions, which is going to be let me go fill struct. So the group is going to be a group for us, and then we need a list of topic partitions, right? So let's prepare planned partitions, and then say so let's make this so this will be Kafka dot topic partition, and then let's specify the length and capacity here. Now we should range through this offset map, and then we need to construct this plan partition. So for underscore, so the first value of our offset map is going to be partition, and then offset is range offsets. And then now what we need to do is we need to create a variable, say let's call it as plan for now. So this is going to be Kafka.topic partition. No. So this is going to be Kafka.topic partition where let's fill the struct. So where the topic here is it's going to be string, so it will be ampersand topic, and the partition here is partition, and then the offset here is offset. And then like we don't need the metadata error or leader epoch for now. So, but we need to check these informations when we get the results. So let's do this. So once we get the plan, we can say plan partition. We can append our current plan to plan partition. And once we have that, we can say planned partitions is going to be our partitions. And once we have this, we can actually say planned group partitions. So first we are constructing our partitions and the topic, and then we are constructing this planned consumer group topic partitions where we link the group name with the previous topic offset construction. So if we find an error here, if error not equal to nil, let's return this error. And we need to check the result now. So result here as consumer group topic partition. So this is very similar to this function here, fetch group offsets. So I can copy the same information from here and then paste this here. So here we need to check here we need to check t.error. If t.error not equal to nil, then we will return t.error. Otherwise we'll return nil. So we are not returning the actual result value here. Like we assume that if the error is nil, then the planned offsets are applied. So let's see. Now before applying, I'm just wanted let's apply. So I'll go to offset 0, and then I'll set this to 1, and then for offset 1 I'll set this to 2. Remember, like in planned offsets, remember for the test topic, for partition 1 we have read 7 messages. So I'm going to reset the information, the offset to 2 for partition 1, and then for partition 0 I think like we have read only 1 message, so technically there is no change here. So I'm going to reset that again to 1. So let's see how it works. Go run main.go. Undefined alter group offsets. There is a problem. Alter group offsets, yes. So here it is going to be client dot alter group offsets, yes. Okay, so our application is, it has ran. Now it technically it did not throw any error. So for partition P1 it has moved the partition from 8 to 2, and for partition 0 technically it didn't do anything, although an alter group request command has been sent. So we should be able to use the same test group name, same consumer group name on the same topic. Now it should read messages starting from 2. Have consume. So let me create another group called it's very difficult to come up with a consumer group name, say CG1, and then I'll try to read from topic test. Is it possible to specify the partition here? Partitions to consume. Okay. Okay. So when I consume from partition 1, so partition 1 offset 2 is the messages R, and then partition 1 offset 3 is the message is U, and then from partition 1 the message 4 is this. Now you can see like it has read partition 0, and then so this is a message from partition 0, so this is our new consumer group, and then it reads message from partition 1, which is our hello message. Now where is our application? Yes, so I'm going to use a test group name which has already read 8 messages in our topic. Now when I run commit test, it is actually reading from partition 1 to offset 2, which is R, and so it is starting from partition 2, and then it is reading until the 7th message, until the last message. Now when I run the application again, it is not going to read anything because we have read till the end. Now let's test this again. Let's read from partition 1 offset 6. Okay, so I go here, I change this to offset 6. This is our planned offset for partition 1. Our planned offset for partition 0 is 0. Let's make this to 0. So now our consumer is going to actually it is going to display 3 messages. One is from offset 6. It is going to display offset 6 and offset 7 from partition 1, and then it is also going to display the only message that is available on partition 0. So let me clear this to clear. So yeah, so I ran this and nothing worked because I did not alter my offset. So clear, go run main.go. So it has changed the partition. Unknown member. Why? Probably let's do this. Probably the offset, something happened to offset. So let's run Kafka consume test group commit test. So it has displayed two messages from partition 1, like this is what we want, which is perfect. So we need to find what is this unknown member exit. Probably so actually our alter partition alter offset is working. We were able to move back in time and set the offset, reset the offset, and then the application is actually reading from that point, from our altered planned offset, which is great. Now we need to check why this is a failing. Actually, say I produce some more messages to partition 0. This is my second message. And one more message. Right now, when I say Kafka consume underscore test, it is going to read two messages from partition 0, the offset 1 and 2. Let me change this to, okay, this is already 0, and let's clear this. Go run main.go. So the offset 3 is changed to 0 and the offset 8 is changed to 6. Now when we run Kafka consume, it is going to read from 0, partition 0, offset 0, partition 0, offset 1, partition 0, offset 2, which is perfect. And then from partition 1, it is going to read from the 6th position here. So this is 6 and here it is 7. Offset 6 and 7 is read. All right, so our application is technically working. Now we need to write some tests. Maybe we can keep that for the next stream. So we and then we can also get both this information from the command line argument. We can say let's call this args as args of 1 and this as args of 2. So what is args? Args is nothing but os.args. So this is an array. So os.args, let's write some god class. So if length of args not equal to 3, so it should have 3 elements. Sorry. So the first element is going to be the name of the binary itself, and the second element will be the topic for us, and the third element it's going to be the group, and then we need to specify the offsets. Right now, let's just get the topic and group, and then we can see how we can get this map as an input. Probably I'm thinking we can read this from a file maybe, or maybe we can keep this enhancement for the next stream. So right now let's read the topic and group. So I'll write an error command line usage, error command line. So the usage is ReOffset, which is our binary name, and then topic name, and then group name. Was dot exit of 1. So let's build the application. So we have ReOffset. Our topic name is test. Our group name is test group. Yes. So it has changed. Kafka consume, and yes, like this is the information that we want. Partition from offset 0 to 2 is read from partition 0, and offset 6 and 7 is read from partition 1. All right, so I'll end the stream right now. We are nearly going to be, it's almost 2 hours since we started the stream. So probably in another stream, we will write some tests for this application, and then we will also properly enhance this application to read the topic and the group offsets, and then the list of planned offsets from a file maybe. So until then, happy coding guys. Bye bye.